Hi, this is Sung. I'm your online math mentor, and we've been going through simple harmonic motion, right? And now we're going to go through a specific example, or a typical sort of example that deals with simple harmonic motion. Now, do you remember that simple harmonic motion is a type of motion where basically something is oscillating, right? Oscillating means going back and forth. It's either going up or down, or it's going left and right in a harmonic fashion. Harmonic meaning a rhythmic fashion or in a predictable, constant oscillating fashion. Okay, so when you have simple harmonic motion, what I want you to realize is that it will take the form of a trig function, either a cos NTC, right? So a cos of a trig function, or a sine of a trig function. Now, what does A stand for? A stands for the amplitude, right? A stands for the how far from the center it goes to the right, how far from the center it goes to the left, or in the case of a vertical motion, up or down. Does that make sense? So that's what A stands for. N, what does N stand for? N stands for the number, right? That will give us the period. Okay, so it's the number of wavelengths inside a 2 pi or 360 degrees range of motion, right? So the period in this case is the time it takes for one complete oscillation. So starting at the center, going out to the right, going out to the left, and then back to the center again. So one complete oscillation will be the period, all right? So it's the time taken to do that. And the other unique feature about simple harmonic motion is that the acceleration is always proportional to the displacement, okay? So the acceleration is always proportional to the displacement at any point along that range of motion where the proportionality constant is a negative, okay? It's going to be the negative of n squared, all right? So let's have a look at this, all right? We're going to look at this example and I'll kind of walk you through how we're going to do it. So a point moves in simple harmonic motion from a point 5 centimeters from the center with a speed of 1 centimeter per second. Okay? The period of motion is 11 seconds. Find the maximum speed and acceleration. Now, what can we ascertain from this question? We can ascertain from this question that the point is moving in simple harmonic motion. Given that it is simple harmonic motion, we can go straight to this formula, A cos nt plus C, right? Now we can either go to that formula or to the other formula, which is in sine form. Either way will work, right? Now, what we know is that the displacement will be A cos nt plus C, right? Which means that the velocity will be negative n a sine nt plus c, which is in fact the derivative of the displacement formula, okay, or the displacement function. And to find the acceleration function, we basically differentiate again to get negative n squared a cos ntc. Got it? Okay. Now, what else can we ascertain from this question? The fact that it's simple harmonic motion means that it follows that set of functions. We also know that it moves from a point 5 centimeters from the center, right? And we don't know whether it's right, left, up, down. So I've put it in absolute value, and that will cover our situation in both cases, right? So you've got the absolute value of x, which is equal to 5, right? We also know that the speed is 1 centimeter per second as well, right? So the absolute value of the speed is 1. Got it? So that's going to be really useful. Now, how do we use all of this information to help us out? Here's what I would do. Let me come over this side just to kind of really be able to use the board to show you what I would do, right? So we know that x, right, which is 5, right, is going to be a cos. Now, we know that t is going to be equal to 0, which means that it's basically, we're left with cos c. Do you see that? Okay. So we've used this information and this information to work this out. We're also going to be using this information and this information to work the next bit out, which is basically that the absolute value of the velocity, so that's 1 equals to, right? Let's have a look. Minus n a, and then it's sine of 0. Remember t equals to 0, which gives you sine c. Okay, beautiful. So we've got this and this. Now, let me just simplify something for you. What is n equal to? Well, we've got to work that out, but we know that the period is equal to 2 pi on n. And we're also told that the period is 11 seconds. So we can say period 2 pi on n equals 11, okay? So let's work out what n is equal to. So n over 2 pi equals to 1 on 11. N is equal to 2 pi on 11, okay? So when it comes to this, we can say that a sine c is equal to negative 1 on n. Do you see that? Because we're going to divide both sides by n and then flip them around, flip the equation around. So n is equal to 2 pi on 11, which gives you a sine c, which is equal to negative 11 on 2 pi. All right, so what can we do from there? We know that's the case, and we also know that that's the case. All right, I'm going to do something really sneaky. I'm going to show you what I'm going to do next. Basically, I'm going to do this. A cosine c squared plus a sine c close bracket squared. Now, when we do that, what we end up with is a squared cosine c plus a squared cosine squared c, a squared sine squared c. Yep. I'll continue over here, which ends up with a squared cosine squared c plus sine squared c. Now, how's that going to look? So basically, we're squaring these two things, right? So we've got 5 squared plus negative 11 on 2 pi squared. All of that is going to be equal to 25 plus 121 on 4 pi squared. Got it? And over here, cos squared and sine squared, it's the Pythagorean theorem, identity, right? So cos squared plus sine squared is going to be equal to 1. So you're left with just a squared. A squared is equal to that, which means that a on its own is equal to the square root of that, which I'm going to now work out. Okay, so hold on a tick. Okay, so that roughly gives us, I think I get it to be 5.298, and that's the 3 decimal places. Okay. So on my calculator, I'm going to put that in my memory. So I'm going to go shift store A, okay, and that's going to be in my memory. Now I also know that n is going to be equal to 2 pi on 11, which I'm also going to put into my calculator. So it's 2 times pi over 11, and that's going to roughly be equal to 0.571 to 3 decimal places. Got it? Okay, now that's going to be really helpful because what we need to find is the maximum speed and the maximum acceleration. So let's work that out. So the maximum speed is going to be when this is a maximum. Do you see that? Because that's a constant, that's a constant. What is the maximum that a sine function can take on? Well, the maximum that a sine function can be is positive or negative 1. It's the amplitude itself, right? So the maximum speed is going to be nt, or na, sorry. And it says negative here, right? But basically I'm going to leave it as positive because speed is a scalar quantity, right? Doesn't have direction, doesn't need to be positive or negative. So what we've got to do is basically work out that value times that value, and that'll give us our answer, okay? So our maximum speed is going to be, and in my calculator, I've already saved those values. I get this, I get And that's, I think, it's basically centimeters per second, right? Cool. Actually, in fact, let's run this way around. Got it? Awesome. Awesome. Now, the next thing I want you to see is basically that the maximum acceleration is going to be, again, when is the cos function going to be a maximum, right? Again, positive and negative 1, okay? So the acceleration is going to be a maximum when you've got n squared a. Got it? Which is n squared a. And again, I could put positive or negative, but acceleration, basically, I'm going to treat it like a scalar, which we then can work out to be, and I get 1.728 centimeters per second squared, and that's going to be to 3 decimal places as well. Got it? Beautiful. So that's essentially how we work out this sort of a question, right? Find the maximum speed and acceleration. Part of what it involves is working out what our n is, working out what our a is, and these two values here, and then using those values to work out what our maximum speed and acceleration are. Thank you very much for watching. Bye.